Generally, I enjoy the Salcon videos. However, there is one video that I do take some issue with. It's actually a pair of videos, and that's the ones on Parabola. Focus and Directrix. Now, the reason why I take objection to these is several things. First off, Sal comments that this form is a very common way to see parabola. And to be perfectly honest, in calculus, I don't know. Maybe that is a great form for calculus. But for algebra, this is not what you're going to see. In fact, if you go to the Wikipedia entry on Parabola, you're not going to see it. If you try and use a reference book, College Algebra Demystified by Huttenmuller, I hope I haven't mangled that too bad, you're not going to see it. You're not going to see it. College Algebra, Huffman Schwitters, College Algebra Trigonometry, Second Editions by Wenser, Pre-Calculus 9th Edition by Sullivan, Beginning and Intermediate Algebra and Integrated Approach 5th Edition by Guston and Fisk. In purple math, you sort of kind of see it in an intermediary step in one of their explanations, and that's about it. So, common? Not that I can tell. The two ways that I do see this equation very, very common is y equals ax squared that is then derived to y equals a x minus h plus all that squared plus k. And then you'll notice something here, and I'll give that to you in a second. And then the other form that you see very, very commonly is y equals 4p x squared. And I should have drawn that up a little further. I'm just going to do my derivative version above it, which is the y equals, and you're going to see that there's no real difference here, 4p x minus h squared plus k. And these are the shifted versions, and these are not. And in the video that Sal did, at one point he shows like b equals 1 over 4a y1 plus y1. That's supposed to be a sub 1, not a I forgot my eraser doesn't work the way I want it to on this one. Plus y1. And you'll see that you've got this 4 here, and you've got this 4 here. Now, one of the other things that Sal says is exactly which variables he uses, which terms to represent variables. He says that it doesn't matter. And I'm also going to disagree with that in this video. Because you see, these little y1s, b 4a versus 4p, small a versus big A, that actually can matter when you are learning in a class. Or using standard references. God, that's terrible text today. My hand's a little cramped up. REF. Yes. Okay. And the reason why I say this is because now you are learning a method that you may have a great deal of trouble translating into something workable in a job or education, etc. What you will see in his examples on his site is also a problem, because he does all this 1/4, 1/2, and you end up with these calculations where, you know, you've got this thing here and it's got some 1/8 in the measure and all the all nice fractions. Okay. These are all friendly numbers. Okay. You don't see that in the world. Okay. When you're dealing with a parabola in the real world, you're dealing with an antenna design, and you've got just the very bottom part of the parabola here, and you're trying to find the focal point so that you know where you've got to mount that so that any ray coming into the dish will reflect into the focal point. This is going to be so many inches, so many centimeters. It's going to be, you know, some value that ends up being 15.728 inches, and you may have something that's so precise that if you don't get down to thousandths or better, you may not get the accuracy that you need. When working on a fountain and figuring out the trajectory of the water stream in a fountain so that you know where to place the spigot so that it comes within a certain distance of the edge so that the splash doesn't go out onto the sidewalk, and you're doing this design, you are not going to have a nice fraction. And when you are in a standard math class, you're going to get these results where the numbers might be 5, 7, 32, whatever, on the graph. So these nice little fractions aren't helpful. So I really recommend that you augment these videos going to Purple Math here, because like I said, they've got a little bit of a transition point. And read through what they've got, and you'll notice one nifty little thing that they state, where you can where it says P equals the distance between the vertex and the focus. Well, you know that the point directly under the directrix and the focus is also the same distance. Okay, so this is P and this is P. So if you're working in a class where they use P, it's that distance. And if you do a little bit of math, and I think they also show it on the Purple Math site, you'll see that A equals 1 over 4P. So if you're used to using the P method, or if you want to figure out P from the examples on Sal's site, where you are playing a game with a little dot to get it here, and you're playing a game with a line to get it here, you can figure out your 4P distance. You can figure out your P distance there and there, and then use the formula that you know, and then plug it into this equation, and then use the results to fill out Sal's online version that looks, if I remember correctly, something like that. So this is the one place where I don't think he does a good job. I don't think it's as applicable, and the video is definitely confusing, but there is a way to translate it more to what you would use. And hopefully I'll have some time to do some worked examples using more of the standard college form.